I recently returned from a Caribbean cruise vacation with my family over reading week, and as much as I tried to enjoy myself, for my entire trip I was plagued by one question. How do cruise ships manage their energy needs? When you think about it, a cruise ship has drastically different energy requirements than a comparable resort on land. Why? Because a cruise ship is a self-contained energy system. It can't connect to the grid in the middle of the ocean. It has to be able to process its own fuel, waste, and water for the thousands of people on board. Energy management on a cruise ship considers everything from the shape of the hull to the lights in the staterooms. In this slidecast, I'll discuss the energy usage of cruising, the difficulties that the industry faces in managing their energy needs, and the challenges and opportunities that cruise tourism will face in the midst of a changing fuel future. You may be asking yourself, why is this an important issue? There were many other relevant energy dilemmas and discoveries out there. Why should we worry about cruise ships? Well, the cruise industry has grown 7.6% annually over the last decade, and the carbon footprint is considerable. In fact, modern cruise ships consume 10 to 12 kilowatt hours per passenger per day for propulsion, air conditioning, lighting, and other amenities. Each person is therefore responsible for about 401 grams of CO2. That means that one cruise tourist consumes the same amount of energy as an entire German household, and a typical cruise ship has 3 times the energy use of a Boeing 747. It's also important to consider the impact that cruising has on the economy. Cruise tourism is a key supporter of many island nations, with port facilities, dockside shopping, and adventure excursions providing a substantial part of their island's income. So, how do cruise ships meet their energy needs now? Ships run on low vibration diesel-electric propulsion systems. Electrical power equipment and motors are driven by generators powered by 4 to 6 diesel engines. These generators range from 12 to 20 megawatts depending on the size of the ship and the number of guests. About 40 to 65% of the generated power goes to the propulsion systems, and almost the same amount of power is used for heating, ventilation, and air conditioning. In addition to this, over 40% of the fuel not used for propulsion is consumed by the lighting system. So you can see that propulsion, air conditioning, and lighting are 3 major areas of the ship's energy system that engineers try to optimize to increase efficiency. Cruise ships face many unique challenges when it comes to managing their energy needs. You think that your family minivan has bad gas mileage? Try navigating a floating hotel the size of a few city blocks. While the physical movement of the ship requires a great deal of energy, the hotel portion of the boat is the big power sucker of the operation. Theaters, casinos, athletic facilities, and a multitude of restaurants make optimizing power allocation a tricky balance between luxury and efficiency. The cruise ship industry is making great strides towards reducing their fuel consumption by employing a number of innovative new technologies. For example, let's look at the new Celebrity Solstice ship, advertised as one of the most energy-efficient cruise ships at sea. The Solstice consumes 30% less energy than comparable ships due to its predictive management technology, energy recovery processes, and super efficient lighting. Predictive management technologies are increasing in popularity as engineers monitor how energy use is distributed throughout the ship over different times of the day. On the Solstice, they have CO2 sensors in the restaurants to determine how many guests are eating, and they can then divert energy flow to the staterooms or kitchens accordingly. Normally, it's not a good thing to be full of hot air, but the Solstice also employs a novel heat recovery system, with which exhaust from the engines is redirected to run steam-powered turbogenerators. This can reduce overall fuel consumption by 10%. They also utilize LED lights in the staterooms, which can reduce lighting power usage by 60%, saving 3,000 tons of CO2 emissions and $300,000 per year. So where is the future of this industry headed? All cruise tourists currently pay a fuel fee, which fluctuates with the cost of oil. So until someone invents a ship that runs on the dreams and laughter of little children, cruise ships will continue to depend on dwindling fossil fuel reserves. Advancements in alternative power sources are rising, but the unique nature of a mobile hotel limits the applications for wind, nuclear, and solar. Royal Caribbean International's new Oasis-class ships, the largest in the world, will employ liquefied natural gas-fueled engines, thereby using 25% less power than similar ships. Some of their older ships have been retrofitted to use biofuel when available, and the Celebrity Solstice is pioneering the use of solar panels at sea. Current improvements are focused on reducing diesel consumption when boats are docked, as each ship can use 8,000 gallons of fuel while in port. In Los Angeles, they're constructing a new portside solar power system, which allows ships to access 1.2 million kilowatt hours of clean solar power instead of using their diesel generators while docked. Improvements to existing port infrastructure and retrofitting older ships may help reduce the footprint of the industry, but the advancements may not come fast enough to keep up with rising fuel costs. Overall, the cruise industry has a large energy footprint that most tourists aren't aware of. Engineers must be creative in their application of different power regimes, as cruise ships cannot accommodate the traditional alternative sources on the grid. The focus is on optimizing efficiency within the system as a whole by monitoring consumption patterns and allocating resources to where they are most needed. With heavy reliance on fossil fuel consumption, the cruise industry may be entering a market that is both unsustainable and unprofitable. In order for cruise tourism to survive, the technological advances must be able to accommodate the demand for luxury, while still achieving the highest possible level of energy efficiency.